In this video, I want to just kind of talk a little bit about relational and logical operators, because again, these are terms you're going to hear, you're going to read about, and it'll make sense when you see them, and you may already know them from other programming. This is not unique to C++ necessarily, but I want to just kind of give you the textbook definition here, talk about them just a little bit, and then you will see them in action a little bit later on in some separate videos out in some actual code examples, okay? But relational and logical operators provide us the ability to make decisions in our program. Now, the program, usually the reason we even have a program is we need to make some decisions. We're going to read some data from somewhere, or we're going to input data into the program, and we're going to compare that data to different pieces of data or conditions, and then branch our program based on that. Usually a program is there to collect data and make decisions based on that data. All right. Now there are two kinds of operators basically in C++ for decision making. That is a relational operator or a logical operator. Now let's take a look at relational first. When we're talking about relational operators, we're talking about an operator that determines whether values are going to return true or false when they're compared. Okay, now this means they're compared based on either equality, which notice is two equal signs. All right, so if I put A equals 3, I'm testing to see if the value of A is equal to 3. If I put A equals 3, just one equal sign, then I'm setting, or I'm assigning the value of 3 to A. So be very careful with that. Assignment is one equal sign. Checking conditionally to see if something's equal is two equal signs. Okay? Not equal is where we simply put the exclamation point in front of an equal sign, and this means something is not equal to. And keep in mind that equality and not equal is also known as equality operators. Now, some publications, some nerds out there will consider equality operators as a third category separate from relational and logical. But equality is also relational, so that's just kind of a semantic difference in some camps. So whichever you are, just make sure you understand these are also known as equality operators. Now, the true relational operators that everyone will agree on is greater than. Notice this symbol means we're checking the condition to see if the number on the left side is greater than the one on the right. Less than, we're checking to see if the number on the left is less than the number on the right. Greater than or equal to is the number on the left greater than or equal to the value on the right. Less than or equal to, obviously, is the number on the left less than or equal to the number on the right. Now, relational operators are always going to give you a true or a false. Doesn't matter how many lines or characters that you're comparing, you're always going to end up with a condition of either true or false. That's how you know you're dealing with a relational operator. Now, a logical operator is where we get the chance to add a little bit more conditions. All right. These are also referred to as Boolean operators, and they just add additional Boolean conditions to whatever comparisons that we're trying to work with in our program. Now, here are the logical operators. The not sign. Now, the not sign returns the opposite Boolean value. So if I have, example right here, if I have exclamation true, then that means not true, which is the same in English as false. If I have exclamation false, it means not false, which again means true. So it basically flips the value, if you will. And is represented as logical operator two ampersand signs. All right. And when we're talking about and in a comparison, it's going to return true if both conditions are true. In other words, we're looking through our database and we're checking to see if someone is in their 30s and they live in the state of Tennessee. Now, if somebody's 29 and they live in the state of Tennessee, one of those is false, and so the condition is going to be returned as false. All right. If they live in Oklahoma and they're 16, both conditions are false and it returns a false. But we said if they're in their 30s and live in Tennessee, so if we find somebody who's 33, they live in Nashville, guess what? It returns true because both conditions are true. Then we have the OR. And OR is represented by two vertical pipes. Now on most keyboards, that is, you're going to hit Shift and you're going to use the key that has the left leaning slash. Alright, not the one under the question mark, but the pipe is above the left leaning slash, usually up there near your braces, right under your delete key. But could be anywhere on your keyboard, just look around for it, okay? Now, when we're talking about an OR condition, this is actually the opposite of the AND condition. This returns a true if either of the conditions are true. Alright, otherwise it gives you a false. So now let's talk about our little condition about the states and the ages. If we're looking for anybody who's in their 30s or live in Tennessee, someone who lives in Oklahoma and is 33 years old will return a true condition because one of the conditions was true. They lived in Oklahoma, they're not in Tennessee, that's false, but they were in their 30s, and so we're going to get a true. Alright, so just keep this in mind. Now you're going to see a lot of these examples, or some of these examples. We're going to jump out into the code and talk about some if statements and some switch statements and some looping and so forth. So you'll see some examples of these, but always, 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 when you get into using the not sign, the and or, make sure that you test it very carefully to make sure that it's not outthinking you and returning a result that you didn't anticipate. Now let's talk about the if statement and what you can do with this thing in your programming. Now, in a separate video that was entitled Relational and Logical Operators, we talked about things like greater than, less than, equality conditions, and so forth. And now we're going to jump into I guess a set of videos here. We're going to talk about how you can use these with various pieces of conditional logic, because we ultimately want to branch our programs. And so in this if example, I'm going to show you how to do just a simple if statement, and then show you just a couple little gotchas with this thing, or a couple little informational things. Now in this video, since it's kind of the first one in this little group of control structures, I'm going to take you through the whole process of setting up these examples one more time, and then for the rest of them in this section, we'll just kind of start out there where the code is. So notice what I'm going to do here is open Visual C++ 2010. I'm going to choose New Project. And then once this comes up, I'm going to choose a console application, and I am going to name this one if example, and then I will click OK, and just take all the defaults that I had there. I'll click next on the application wizard, tell it to give me an empty project, and I will leave it on console application, and then click finish, and it's going to gyrate for a minute and click and hum. And then it will present to me a coding environment for this particular Win32 application project. Now when it comes up, keep in mind that if I look in the Solution Explorer, yours could be over here on the left side, mine's on the right. If I expand this, you'll see that it has a lot of things there for me. I'm going to right click on Source, add a new item, and now I need to add an actual file, a module to hold my C++ code, and I'm going to call this if code. Now keep in mind, you will have the finished working version of this example in your work files folder, so go take a look at that if you want to avoid some of this. Then I'll click add to add my C++ file in, and there you go. And I'm going to unpin this toolbox so it'll get out of the way. And so now what we need to do is put in our basic code here. And then notice we would have our int main, right? And then I'm going to put my return 0 down here so I don't forget it. It'll probably run without it, but you should have it in there, okay? Now let's talk about a very simple if statement. Let's say that up here at the top we create an integer, a, and we go ahead and load it up with 14 as we create it. Alright, so there's our integer 14. Now because of the scope, if you've watched those videos, you know the scope of this is kind of class level, and it's going to be available for all of our functions, and so we'll be able to see it just fine in main. Now let's do an if statement. Very simple, kind of a useless program here. If a is less than 13, then if a is greater than 13, then let's let it tell us that something's a problem, it's too high. Okay, so the way we do that, we just write an if statement. If, and notice we have to put it in parentheses. If a is greater than 13 in our parentheses, then what's going to happen, notice when I hit enter, it automatically indented me. I'm going to write out to the console, and I'm going to say the level is getting high. We're just going to send a warning out, say, hey dude, the level's getting high. Okay, and there we have it. All right, and that's all I have to do. And I'm going to bring some lines up to take them out of there. Okay, so now if I compile this and run it, so I'll tell it to run it in debug here, and this will compile it for me, and I should see it flash. Notice my output is over here on the right side. I could drag it down to the bottom. I'll leave it here for now, and it'll take my virtual environment just a minute here to build it. Everything worked. There's the little flash of the window. And so what I'm going to do now is actually go out to my projects folder, and I'll go to documents, and then I will go into Visual Studio 2010, my projects. There's my if example, and the executable that I need is in debug. So the Windows 7 trick, I'm going to hold down the shift key, right click on debug, and let me just undo all that. Okay, let me just show you one time. In debug is the executable that I want. So I'm going to hold down shift, right click on debug, and say open in command window here. All right, if I don't hold down the shift and right click, I don't see it. So I hold down the shift, I see open command. Now once I get there, notice if I do a directory dir, you will see my example, if example. So all I have to do is I'm going to clear that and type if example, and you'll see that it says the level is getting high. Now why did it say that? Because let me make this go away. A is 14, and if a is greater than 13, the level's getting high. Now here's what's going to happen. If this is true, there's an assumption, you don't have is true out here, but if this is true, if a is greater than 13, then we're going to say that the example is getting high. And a is equal to 14, so a is greater than 13. All right? If I say a is greater than 16, and it's not, it's 14, let's rerun this. And you're going to notice something here. We shouldn't get any code back. All right, and so I will once again jump back out here. Notice I left my window open. I'll hit the up arrow to repeat the command, and nothing happened because we didn't need it. So here's what's going to happen. If this condition is found to be true, then the next line gets executed. And I can hear some of you yelling, well, wait a minute, dude. What if I need more than the next line to execute? Join me in part 2 of the if example, and we'll talk about that very situation. Welcome to part 2 of if statements, and we're just going to start right up where we finished in part 1. And if you'll recall, in part 1, assuming you've watched part 1, we just did a very simple statement. We created a variable a and loaded it with the value 14, and then we checked to see if it was greater than 16. And since it was not, since this is false, then this line didn't work. But let's do something here. Let's say that if a is greater than 12, then we're concerned because when it hits 14, something bad happens. All right, don't know what that is, but let's just go with that. Well, let's assume that, okay, so we're going to tell them the level is getting high. Let's write something else out here. Let's just say, there's our standard namespace, COUT. How about let's say something like, refer to procedures for reducing the level. You know, we could tell them what page number, shelf number, all that kind of stuff if we would like, but for now we'll just let this be it. And we've got a little bit of a challenge here. All right, if this is true, or actually I should be saying if this is true, then it's going to take the next line. All right, well, let's see what happens when we run this. Then we'll change it up a little bit, see what happens. Then we'll actually try to correct the issue. All right, still have my window open from before, and I'll hit clear to clear this off, and then just hit my up arrow key, and it will remember my commands. Now notice, well, this did okay because A is at 14. If it's greater than 12, then print out that the level's getting high and refer to procedures for reducing the level. Well, it looks like everything's okay, but let's do one other thing here, okay? Let's say that if A is greater than 15, all right, what do we want to have happen? Well, it shouldn't put this out because A is 14 and A would be greater than 15, right? Okay, let's make this 16, all right? And let's say if A is greater than 18. Let's make it that way, all right? So A is 16, and then here I'm going to say if A is greater than 18. Now A is right now not greater than 18 because we're checking to see what this level here is, or this value here is, all right? So it's not greater than that, so that it shouldn't print these two out, correct? Well, let's compile that, and let's see what we get. And so I will jump back out into my window. I will clear it out. Go back and run my example. Now notice, kind of interesting here. This equated to false, right? And so it didn't print this out. However, notice it did print out the refer to procedures for reducing the level. Why? Well, our logic says if this is true, write this one, okay? And since this wasn't true and it didn't write this one, then it said, okay, well, that's okay, so let's go ahead with the rest of the program. So I'll start right here and just start putting things out there. Well, wait a minute, I need both of these to happen. So what are we going to do? We're going to use our old friend, the braces. And we're going to basically tell this, look, I know there are two lines there, but I want you to treat everything within those braces as what you do if this is true or what you don't do if this is false, all right? So I will compile this up, or I will build it. And then I will go back out to my window and clear the contents of my window. Use my up arrow key to get my old cached commands. And now notice nothing's coming out. Why? Because A is not greater than 18. It's only 16. So neither of these printed. All right. So this was false. So neither one printed. All right. Now let's go back and say, is A greater than 13? And it's 16, so yes, it is. All right, and so I will rebuild this one, and then you will notice now this time that we're going to get both of those. Now we're getting them again. All right, take a very simple example like this, go over it and over it, play with it, get it straight in your mind what's going on. Very easy to confuse yourself. All right, and make sure when you're writing these codes that you test them in such a way that you can follow it and understand what's going on, or you will introduce errors. Keep in mind, there's nothing syntactically here that's going to throw an error for me. But if I let my little brain get confused over what I'm checking for and what the value actually is, I could introduce errors into my code that would be very, very hard to come back and find. Okay, so anyway, that is a good brief example in a two-part video on the if statement.